In section 2.2, we're going to talk about how to create a frequency distribution table given some data. First, we want to take a minute to talk about the characteristics of data. So kind of what we can talk about with data. So one of the first things we might want to know about the data is where is the middle of the data? And the special word for this is the center. Okay, so where's the middle? And in chapter 3, we'll talk about averages and different ways to talk about that. Another thing we might want to ask is how much do they vary? How much do they change? And this is called the variation. We also want to know kind of what the shape of the data is. If we made a graph, would it look like a bell-shaped graph, or what would it look like? And this is called the distribution. So it's a fancy word here for shape. We might want to ask, do any of the data values lie far away from most of the other data values? And so if there are values that lie far away, these are called outliers. So these would be data points that are really outside what's normal. And then the last thing we would want to talk about time. How do the data values change over time? So for example, if we took a survey about computer usage 20 years ago, it would be much different than computer usage today. So data changes over time. So you want to know how relevant is your data at the given time. So there's just a little mnemonic device, just a little way to remember kind of these things that we look at. So mnemonic device here. So to remember these 5 things, there's the little sentence, computer viruses destroy or terminate. So the C stands for center, the V stands for variation, the D stands for distribution, the O stands for outliers, and the T stands for time. So you don't need to memorize the order of these words, just something you can always think of what you would want to know about data. So now let's get into frequency distribution tables. So the purpose of using a frequency distribution table is to be able to, we want to be able to organize the data to help us understand the distribution of the data. And so remember, the distribution is a special word for the shape of the data. So how, if we drew a graph, what would it look like? Does it start up high and go down low? Does it start up high and does it start low, go up in the middle, and come back down? What is the data doing? So we're going to use this example right here. We've got 24 math students who took a test, and we've got their test scores. Okay, so you can see they range anywhere from 98 to 64. So the first thing we need to talk about a frequency distribution is what's called the range of the data, and we'll be using the range throughout the class. And to find the range of a set of data values, we take the maximum value and we subtract the minimum value. So what we're really saying is how far apart is the highest value from the smallest value. So for our data set above, our highest value is 98. And if we look closely, our lowest one is 64. And so we get our range is 34. So we're going to use that when we get to our frequency distribution table. So now what the frequency distribution table looks like is it's actually a 2-column chart. And in one column we're going to have what are called classes, and in the other column we're going to have frequencies. So the classes are categories or intervals that will put the data in. Now, how many classes you have sometimes affects how the shape looks. And so you want to be careful not to have too few classes or too many. And our book tells us that normally, out in the real world, you would take somewhere between 5 and 20. Sometimes you'll see in just a second we'll break this rule just for simplicity if we're doing it by hand, but it depends how big your data set is and so forth. So we're only going to use 4 classes, so we're already breaking our rule. So first we need to come up with how wide is each of our intervals going to be. This is called the class size or the class width. And to do this, because all of our classes need to be the same size, to do this we take the range, we divide it by the number of classes we want, and then we round up to the next whole number. So for our frequency distribution table that we did above, we had our range was 34, and we want 4 classes. So if we divide 34 by 4, we get 8.5, and we're going to round this up and use the number 9. So our class width for our example is 9. Okay, so on the next page, we're actually going to go ahead and create our frequency distribution. So I'm going to write it up here at the top to remind us that our class width is 9. Okay, so the first thing we do is we want to start with the lowest value, and sometimes we'll round down for different reasons. We're going to start with our minimum value. So our minimum value is 64. And we want to create our intervals. So what we're actually going to do is create the lower bound for each of the intervals, and then we'll fill in the upper bound. So to get the next lower bound, we'll add 9, our class width. So 64 plus 9, our class width, is 73. Then to get our next one, we add 9 again. So that would be 82. Remember, we wanted 4 classes, so to get our last one, we add 9 again and we get 91. Now, it's often helpful to write down, what if we added 9 one more time off the side? That would be 100, and that will help us get our upper limits. So now our upper limits will be 1 less than what we have for the next lower limit. So since our for the second class, our lower limit is 73, the upper limit for our first class is 72, 1 less. Okay, and this one would be 81, 90, and here's why writing the 100 off to the side is helpful. We see that our upper limit here should be 99. Okay, now we look back on the previous page, we look at the 24 tests, and we count how many of them are between 64 and 72. And if you count carefully, I recommend kind of marking off the ones as you count them. We'll see that we get 15. And then between 73 and 81, we get 4. Between 82 and 90, we get 3. And between 91 and 99, we get 2. Now, one check you can do for yourself is that your frequencies should always add up to the total number of data values. So since we had 24 students, our frequencies should add up to 24. So if we check 15 plus 4 is 19, plus 3 is 22, plus 2 is 24. So it doesn't guarantee we're right, but at least gives us a check. Okay, so that's all there is to making a frequency table. Now we're going to talk about a couple of different types, 2 more different types of frequency tables that we get after we make our regular frequency table. So the second kind is called a relative frequency table. And our intervals are going to be exactly the same, but to get the relative frequency, we divide each frequency value by the total number of data values and then we multiply by 100% to make it a percentage. Okay, so like I said, our intervals are exactly the same. So we're going to make a relative frequency distribution for our test scores from above. So our right-hand limits will be, so here we've got our right-hand limits, same as before. Now to get our relative frequency, remember we had our total number of students was 24. So to get our first relative frequency, since 15 was there before, we take 15 divided by 24, and then we multiply this by 100%. So here we get 62.5%. And then for the next one, our data value was 4. So we would take 4 divided by 24 and multiply it by 100%. So the number we put there would be 16.7%. Okay, and so on and so forth. So our next value is 3, so we take 3 divided by 24 times 100. When we do this, we get 12.5%. And then last, we would take 2 divided by 24 times 100. And then we would get 8.3%. Okay, and when you add all of these up for a relative frequency, these should add up to 100%. Okay, and then the final type of frequency distribution table is called a cumulative frequency. And to do that, we change our limits a little bit, our intervals. Now we want to talk about everything under some number. So our first category, we're going to say how many scores are less than 73. So that would really be our category before of 64 to 72. So we knew there were 15 of those. Well, then we want to know all of them that are less than the next category. So less than 82. Well, those would be all the ones that were between 64 and 72 before. So that'd be 15 of them. Plus the ones that were between 73 and 81 before. So that's 4 more. So we would get 15 plus 4. We would have 19. Then we would want to know how many are less than 91. And that would be actually the first 3 from before. We would have 22. And then if we ask, well, how many of them are less than 100? Well, that's all of them. So that's all 24. So cumulative, they're always going to always be increasing, getting bigger. And your last number will always be the total. Okay, so just to talk a little bit about distributions, the shapes. So shape or distributions. First, we're going to talk a very special one that we'll see a lot in this course, and that's called the normal distribution. And this is one that has what's sometimes called a bell-shaped curve. So when we have 2 things that happen. The frequencies start low, and then increase to 1 or 2 higher frequencies. So then they get bigger in the middle, and then they come back low. And the important thing is they do this symmetrically. So if we drew a graph, it would be a nice bell curve where it goes up and it comes back down the same way. Okay, so some different types of distributions. We just talked about normal, so a picture of that is, like I said, a nice bell curve. Okay, skewed left means we've got a tail to the left. And so this means it starts low and gets higher. Our frequencies would. So it would look like this. Skewed right is the opposite. It starts high and they get low. They go lower. Okay, and then uniform is when they're all the same. So a graph would actually just be a straight line across. Okay, so in this section we talked about frequency distributions, how to create them, and then also kind of some of the shapes they can take.